right, hi guys. Today we're going to look at 213 part 2, which is the same thing as what we've been doing, but we did equations last, so now we're going to look at inequalities. So these two properties are the important part. There's going to be two more that we'll look at in just a second, but it's the same idea. So if b is greater than 1, meaning if I have a base of an exponential, okay, that's greater than 1, like 2 to the x or 3 to the x, and that is increasing for all x values. Okay, looks something like that. That means that if I have something like this, b to the x is less than b to the y, then it's just going to follow then that x is less than y because it's increasing. Now, where it gets a little bit tricky is if I have a base like 1/2 to the x, okay, that is between 0 and 1, then that means we know that it's a decreasing function that looks like this. So essentially, if you have something like b to the x is greater than b to the y, then x will be less than y because it's decreasing. So for example, if I had 1/2 to the second and 1/2 to the third, this is 1/4, this is 1/8. So even though 2 is less than 3, 1/8 is let me say that again. Even though 2 is less than 3, 1/4 is greater than 1/8. If you have 1/4 of a pizza, that's more than having 1/8, okay? So just keep those kind of properties in mind. So let's look at example 16, A and B. So I can rewrite 125 as 5 to the third power, which then, if I'm raising to a power, I can multiply the exponents. All right, this base of 5 is greater than 1, so I'm going to be looking at the first property, which means the sign is just going to stay the same. So x is greater than 3x plus 18. Okay, so I'm going to subtract 3x on both sides. And then divide by -2. Don't forget that if you are dividing by a negative with an inequality, that the sign is going to flip. X is less than -9, or you could say -infinity to -9. Okay. All right, let's look at part B. 1/3 to the 2x plus 9. Well, let's go ahead and rewrite 1/27 as 1/3 to the third power, because 3 cubed is 27. All right, when I'm raising to a power, I can multiply my exponents. All right, now here my base is 1/3, which is between 0 and 1. So we're going to say then essentially your sign is going to flip because it's a decreasing function. So you're going to say 2x plus 9 is greater than or equal to 3x minus 9. Okay. All right, so then just solving an inequality. Add 9. So this says x is less than or equal to 18. These all say the same thing. Okay, so you get something that looks like that. All right, let's do it now with logs. Same idea, inequalities. If b is greater than 1, meaning if you have a base that's greater than 1, okay, then if log base b of x is greater than log base b of y, then x is greater than y. Same exact thing as we looked at. If we have a base between 0 and 1, then notice that we have opposite signs because that's a decreasing function, okay, which number 3 says the same thing as number 2, just opposite. All right, so let's look at this one. First thing I notice is let's move that 2 to the back as an exponent. Okay. All right, well, my base is 2, so we're going to follow that property number 1 that says the signs will essentially stay the same. So 9 is greater than x squared. All right, this one's a little bit tricky. It's a quadratic. So we're going to have to use what we know. I'm going to subtract everything over to one side. So this is saying x squared minus 9 is less than 0. All right, you can make a sign chart, or you could say, well, that's going to be x plus 3, x minus 3, which would be x equals -3 and x equals +3. So my quadratic will look something like this. We're looking for where it's less than 0, where it falls below the x-axis, and that's going to be between -3 and 3. Okay. Oh, yeah, where it's less than 0, okay? Another option that you would be able to do is you could make a sign chart. You have -3 and you have +3. If I plug in 0, that's negative, okay? So what you're going to do here is put the positives on both sides, okay? So then what I have going on is I have a positive and a positive. So then I'm going to look at in between. I have -3 to 3. Okay, now the only problem with this is x can't be -3 because inside my log, that's going to cause a problem there. Okay, so the only thing that I want here is I want to say then that 0 to 3, and it can't be 0 and it can't be 3, because if x is anything negative, then that log is not going to work. Okay? All right, so again, all we did right here was we followed this property, okay, that if what's inside the log, that's going to be greater than that. Okay? Same thing right here that's kind of happening. Okay, so I'm going to rewrite this as 2. I'm going to put this in exponential form. 2 to the third is less than or equal to 2x plus 1. Okay. All right, so what I have here, okay, is, I need to redo this because that's not right. And stop